we are going to start with UART. UART communication. UART communication is serial communication. It's a kind of serial communication. In our PC, we'll have a COM port, a communication port. We'll connect one serial cable from our any one of the UARTs. We have two UARTs, UART 0 and UART 1. We'll connect our serial cable from that UART 0 or UART 1 to our PC, so that microcontroller can actually communicate between to PC and receive any characters from PC. Okay, so when communication will happen between microcontroller and PC, it has to happen at a certain rate. It has to send bits at that rate only. That's called baud rate. Usually, how much baud rate will it be is 9600 multiples of it. That means in 1 second it is sending 9600 bits, or it is able to receive 9600 bits. It is very important that our microcontroller is at one baud rate and our PC also should be at the same baud rate. There should be sync between transmitter and receiver. Okay, that's how serial communication happens. So UART is one of the peripherals of our ARM7. Because it is one of the peripherals, to write programs you need to configure set of registers in UART. Okay, so what registers you have to configure, you have to go through the data sheet. So first step will be to see all your pins by default are what pins? Input or output pins. How many ports do we have? Two ports, port 0 and port 1. How many pins do we have in total? 64 pins. How many are usable? 45 are usable pins. The rest of them are other dedicated purpose. Okay, so 32 and 32. Division goes like that. So all your pins are default general purpose input or output pins. If you want to use UART, you need two pins. One is the receiver pin and one is the transmitter pin. So two pins, if you want to use those two pins, you have to first find out which two pins. First step is to find out which two pins. And how will you, after you find out which two pins, you have to configure in the one register called pin select register. That is the register you have to use. So how do we configure? By looking at the pin connect block. Pin select 0 register. We have three pin select registers: pin select 0, pin select 1, pin select 2. Every register is how many bit register? How many bit register? How many bit register? All registers in ARM are how many bit registers? 32 bit register. ARM is a how many bit microcontroller? How much bit microcontroller? See, every 8051 is how many bit microcontroller? 8 bit. But ARM? 32 bit, 64 bit. Don't keep guessing, you should say it on the spot. 32 bit microcontroller. It's a 32 bit microcontroller. So all registers are 32 bit registers. Okay, 32 bit registers lo, if you have 32 bits, you'll represent in the form of 8 bits, 8 nibbles in hex format. Okay, if X is a register, 32 bit register, you will represent using 0x0000. Suppose if it contains all zeros, 0000. So totally there are 8. These are called nibbles. Each nibble consists of 4 bits. So enta bit avutundi? 32 bit. That is the representation of any register in ARM. Okay, so 32 bits ni you have to club. First 4 bits enta value vastundi, next 4 bits enta value vastundi. Based on that you will write the hex value. This is clear? So next step entante, you have to configure your UART. So you require two pins, transmitter pin and receiver pin. So pin select register is also 32-bit register. Gani mana port pins, each pin requires 2 bits. If each pin requires 2 bits, pin select 0 lo how many pins can it accommodate? 2. Each pin ki 2 bits. So how many pins can you have in a pin select in one pin select register? Each pin requires 2 bits. 2. There are 32 bits. Each pin requires 2 bits. How many pins? 16. 16 no? Each pin ki 2 bits aithe 16 pins 32. So that's why you'll have pin select 0 16, pin select 1 16, pin select 2 16. So first you have to see ekkadundi mana transmitter, where is our transmitter, where is our receiver pin. Transmitter pin here is here, receiver pin is here. Now tell the value of pin select register, pin select 0 register. Write it in your books and tell me. P0.0 ki the value is 01. Write 01. So after you configure transmitter pin and receiver pin in your pin select register, next step is to initialize the UART and start the UART. To start the UART, you have to set the baud rate, until the rate at which information has to get transmitted from a microcontroller to PCA to microcontroller. To set that, you need to again configure registers. What registers? The first register is LCR. See, you have to first register, you have to call LCR register. LCR register is also 32-bit register. Okay, so total 32 bits lo only 8 bits are used, migitavani zeros. You have to configure the first 8 bits. So you see, 0th and first bit is for character length. We will decide how many character length. So it will be 8-bit character length. So what will be the value? Rayandi? Come on, all of you write in your papers. 3. 0th and first will be 1 1. Okay, stop bit is 1 stop bit, so 0. Parity enable is 0. Parity select is 0. Break control is 0. Write the values. You have to tell me now what value should be. So rest of it is zeros. The last 8th bit and the 7th. It will start from 0 gada. So 7th bit will be 1. You should make it 1.
Parity bit ante 0 1 ante you rasi UART 0 donu.
Ante it is to enable this parity, enable cheyala odda. This will select how many stop bits. So by default it will be 1 stop bit, disable parity, or everything will be zeros. The last 7th bit will be 1. So what values are you getting in LCR register? Write it. ఏమొస్తుంది? How will you start your C program? C program में how will, with what function will you start? Huh? Main, void main or int main. So first step is to configure pin select registers. So after you configure pin select 0, next you are calling this function. This is function call. You should specify the name of the function. If function wherever it is written, it will go there. Okay, after it goes to the function, ఇక్కడ చూడండి LCR became 83. Okay, next step ఏంటంటే to calculate your baud rate. Baud rate we will decide that it should be 9600. Okay, now something you should pass that value to some register so that microcontroller will understand that it is at 9600. So there is a formula for baud rate. Baud rate is PC clock by 16 into divisor value. Divisor ante you are going to move, so cross multiply cheste what will you get? You have to find out divisor value.
16 into baud rate.
PC clock by 16 into baud rate. Okay, PC clock is how much by default? 15. No, 15 megahertz.
15
Crystal oscillator frequency is 12 megahertz. After going to PLL, whatever frequency comes out is 15 megahertz by default. And we can change it to 15, and 15 is default. We can change it to 30 or 60. Okay, so if we want 9600 baud rate, so what will be the formula? Use a calculator. So PC clock is 15 megahertz divided by
16 into 9600.
So you are getting this in decimal value. You can move it in decimal or hex. Hex lo cheste you get 61. Okay, see, divisor ki there are two latch registers. One is DLL, U0 DLL, one is U0 DLM. So U0 DLL lo you have to move the least significant byte of the calculation result. Least significant byte enti man result lo byte. This is bit. This is hex value lo. This is enti 8 bits consists of 1 byte. So 61 is a byte.
Okay.
61 is the least significant byte. మన calculations లో most significant byte enti 0. So DLL lo you have to move least significant byte. DLM lo you have to move rest of them. So ikkada what we did is we generalized formula ni, instead of moving specific values we generalized. Ante we can change, మన ఇక్కడ baud rate change చేస్తే కూడా values automatically it will get calculated and will be moved. General formula is written. So DLM లో move చేయాలంటే, because it will be in the most significant byte position, DLM లో move చేయాలంటే you have to right shift it by 8 result ni. See, if you have a result that which is like 0x4561, ఇప్పుడు DLL లో 61 is moved, DLM లో 45 is moved. So if you want to move 45 into DLM, right shift it by 8 bits. If you right shift it by 8 bits, resultant will be 0x45. Correct?
Yes.
So that's why we are doing right shifting. Because we don't want 61, we only want 45. Suppose we only want 61, manaku 45 oddu. So do AND operation with 0xFF. If you do AND operation with 0xFF, automatically 45 will become 00. So 61 result migulutundi kabatti you are moving it to DLL. So DLM lo you are right shifting it by 8 bits, DLL lo you are ANDing it with 0xFF. Clear? So after that, because you made it 1 here, why did you make it as 1? To enable these registers which are called latch registers. So once this operation is done, disable the latch register by making this bit as 0. By making this bit was 0. If you make this bit as 0, you will get 0x03. So that's why you got 0x03. This is initializing the UART. Ante you are setting the microcontroller to work at a certain baud rate. In our example, it is 9600 baud rate. Okay, clear? Till here it is clear? Next step. What we are trying to do is we are trying to send a string from our microcontroller to our PC. After, how to send that string? Okay, we are using one function called this one. This function of what will there be? We have two registers. One is transmit holding register, one is receiver buffer register. Transmit holding register, when we use is whenever you are sending data from microcontroller to our PC, we make use of this register. It is 1 byte register and it can hold 1 byte at a time.
Transmit
Holding register U0THR. Okay, if you want to send some name like unistring, if you want to send unistring, you have to first send U 1 byte at a time. E register loki you have to send U. Next time you have to send N. Next time you should send I. That is how process is there. Okay, you have to send 1 byte at a time. So what you are doing is you are sending, because if you can't send all the bytes at the same time, until you should see whether that register is empty or not. Only a register lo move chesin tarvata it should be able to transmit. Only when it becomes free, next time malli character ni receive chesukogaladu. Correct? So okesari you can't move all the characters. So what you will do is you will check for one flag in a register called LSR register. Okay, LSR register lo will go to LSR register. Line status register. Okay, what we are doing is we are checking for flag. These two positions lo we are checking. Either this or this position you can check. If this bit is 0, it's also 32-bit register. 5th bit 0 unte it contains data. If it is 1, that means it is empty. So in this part we are checking whether it is empty or not. Okay, we are ANDing with 0x40. If we are checking till it becomes 1, we want it to become 1. If it becomes 1, that means it is empty. If it is 0, that means it is containing some data, so wait. So ikkada em chestund, it is waiting anamata. Till this becomes empty, it is waiting. When will this become empty? When it is successfully transmitted PC ki transmit chesin tarvata it will be empty. So ikkada em chestamante 1 byte at a time we are sending this string, next robotics, this whole thing we are sending. So ikkada em chestundante first it will send N, next it will send E, next it will send X. So ikkada each time it is checking whether that flag is empty or not, that register is empty or not, it is checking. Okay, clear?
40
Why 40 is, you can check 5th or 6th bit. 6th bit check chestunnaru, and again it's 40. If you are checking the 5th bit, it will be 20. Correct, no? So after you transmitting this entire string, what we are doing is we are waiting for the user to press one character. Ante PC will send a character. Ante our microcontroller is receiving. Transmission అయిపోయింది. Now it is waiting for us to type a character. Ante it is waiting to receive a character. Till when will it wait? Till we enter it will wait. Ante because ultimately maname kada, we have to enter it on the PC, so it is waiting. So to wait, it should check for this flag LSR lo the first bit. If it is 0, it is empty. If it is 1, it contains data. Same like this. So it is waiting till it becomes empty. So ikkada wait chestundi ante what it is doing, it is actually waiting for us to type a character. Once we type a character, it is sending the second string, test passed in. Same process, u0thr lo పంపిస్తుంది. See, ikkada what we are doing is we are only waiting for a user to type any character. If you want to see what character user has typed, that will be in a register called u0rbr. Okay, u0rbr అనే register లో you have to copy into one character. మనమే character declare చేసుకుని like char c, we have to copy from u0rbr to c. So that is the program. Understood? So you can see it on the directly result on the simulator. You are checking for UART once a run. So first it said next robotics idantha transmit chestundi. Next robotics ARM development board send any character to continue. Ante it is waiting ippudu mana character to continue. మనం ఏ క్యారెక్టర్ అయినా ప్రెస్ చేయొచ్చు. ఇట్ విల్ సే టెస్ట్ పాస్డ్. ఓకే, టు వ్యూ our result on the PC, I mean with the board, we should go to something called terminal, hyper terminal or terminal. Connect using COM6. Say connect and 9600 baud rate. To run your application, you say reset. I said reset, it displayed this. Press any character to continue. If you want to type any characters, you should type it in this area. So I'll type a character, it said test fast. Okay.